Our topic for discussion today is object composition. Composition is the primary mechanism of reuse in an object-oriented language. So we're going to look at some ideas of what composition is and what it's all about, and then put it into action with a couple of simple examples. Now, composition is simply the way in which something is put together or arranged, and we see this idea quite a lot in ordinary life. For example, a recipe to make a cake. A cake has certain ingredients. So if you like, we compose the cake, okay, from these different ingredients. Much the same way, we do that kind of thing in a programming language. But we use composition for the following reasons. And it's important that people understand the concepts as opposed to the nitty-gritty, because composition itself happens to be quite an involved area. There's many different types of composition, and we'll discuss these things as we go through this course module and a couple of other modules. You will have an OO theory throughout the software development program. Okay, so in terms of composition is the primary element of reuse. So that's what it's about first and foremost. It's about reuse. Reuse of what? Reusing existing objects that have been completely tested and using them in a different context. And composition in an object-oriented language is the main mechanism of reuse. Composition is also one of the 5 pillars, okay, or keystones, okay, of the object-oriented paradigm. If you remember the other ones, we've looked at 2 of them already. Those were abstraction and encapsulation. Composition, and then the other 2 are inheritance and polymorphism. Composition, folks, has a lot of different forms, okay? So I'm just going to briefly describe what they are. All the forms create what's called a dependency. That means an object is dependent on some other object. And that dependency can be in the form of what we call a simple dependency. It can be what's called an association. It can be an aggregation. Or it can be full composition. And we'll see that the form of dependency is really a factor of the scope of a particular variable or object type. And it's important that people understand that that's all there is to it. So composition is simply a mechanism for reusing existing objects to create new objects. Okay, so if we have a look at a concrete example of what that might look like, let's consider the example of a student and one of ye people. So I have a student, and we have a student class, let's pretend. So here's our student class. Now, our student class is effectively going to be composed, that is, it's going to act as a container for some other things. Like what? Well, I'm going to have something like a student ID. So we're going to have to contain some kind of a student ID. The second thing is we're going to have something like a date of birth for a student. I might want an address. And these are all classes, or they're types of some shape description that we might want to share. So here's an address object. And finally, the student may have a course object. That's just some information that makes up what it is to be a student. And just to keep things, just to allow us to illustrate other ideas basically, let's imagine that for all of this the student needs a collection of books of some shape or description. So So we're saying that these are all of the things that a student is. These are all of the things that go to create a student. So a student is composed of these types of elements. Now, another way of writing this is to say, or to think about it rather, is to say that a student has an ID, a student has a date of birth, a student has an address, a student has a course that they're signed up for, and a student has a set of books. And we call this, folks, the has a rule. In other words, whenever you can talk about the relationship between two objects in the context of has a, basically it means we should be talking about a composition relationship. So it's important that people understand that we have something, something, a whole made up of separate parts, okay? And that these parts, the date object could be reusable somewhere else, say in a financial transaction. An address object could be part of a credit card, not just for a student. A course object could form part of something like a module or a degree program. Even at a really abstract way, it could be a golf course even. Okay, and books obviously can be used in a load of different categories. Books for students, books for people in the law library, books for ordinary people, e-books, there's lots of different types of books. Okay, so just to rephrase, okay, the whole notion of composition relates to the creating or aggregating together of objects, reusing existing objects in a different context. How do we do this? So, well, what we need to do, folks, is we need to create some type of a class. And the class in this case is going to be something like student. So I'm going to put in a visibility modifier and we're going to call the class name student. So we're going to put in a visibility modifier of public. Okay, the name of the type we're creating is a class, and the name of the class is student. And what we'll see, folks, is that it's all about scope. So we put in our opening and closing curly brackets. So anything defined up at this level here, it has class level scope. So if we define those different attributes we saw there a moment ago of a student, such as the ID, the date of birth, the course, the collection of books, etc., and we want to reuse them at a class level, we need to define them up here as instance variables. So we could put in something like this: private. It's a string, variable type, and we call it ID. That is composition. I'm composing a student with a string called ID. Okay, private. Date. That's a java.util.date, and we really ought to import that up on top. I'm going to call the date DOB for date of birth. Private. We put a course object in here. I'm going to call it course C. I have an address for the student, private. We call it address. Sorry, the type is address. I'm going to call it A. And finally, I've got the collection of books. So there's lots of ways of storing a collection, but we're going to do it in the most primitive, simplest way. And that is to use an array. So an array of books. And I'm just going to call it a book array. I'm going to call it books. Okay. So they're all defined here. And all of these are instance variables. Now, an important thing to note is these have all been defined outside this class student. The string is a java.lang.string, and I'm reusing the string functionality in student. I'm composing a student with a string ID. I'm also composing a student with a date of birth. I'm reusing the java.util.date in this context to represent the date of birth for a student. Course is defined in its own class somewhere else, and I'm reusing that, okay, by composing student with a course. Address, likewise, is defined in a different class somewhere else, and I'm reusing the address class here inside the class student. And finally, I have an array of books. The class book is defined somewhere else, and I'm building a collection of books that represents the textbooks that the student is using for a course that they're doing. So the whole notion here, folks, is that the student is acting as a container, and the contained things are part of the composition of a student. And the has a relationship holds here. A student has an ID, a student has a date of birth, a student has a course that they're doing, a student has an address that they live at, and a student has a set of books that they're, well, at least meant to read. At that level, okay, this is the third and fourth type of composition that I mentioned, and that will do amply for the moment, for your understanding. And what it means basically is this, that anytime we have an instance variable and the has a rule applies, we are using one of those main forms of composition. In this case, it's either an aggregation or it's full-blown composition. It's all about scope. These are defined at a class level. These instance variables, i.e. the objects that the class student is composed with, are all visible at a class level. That is, any method we put now below here in the class can see those variables. But because these variables are private, the variables that the student is composed with are not visible. Okay, the private keyword makes sure that this string ID, the date DOB, the course C, the address A, and the array of books are not directly accessible from outside the student class. Okay, and what we're doing really there is what we talked about the last day was encapsulation. I'm encapsulating the objects that a student is composed with inside the student class, and I'm effectively shielding the user of the student class from the effect of me changing these. In other words, I'm effectively hiding this information. These are instance variables. So again, to recap, a student has a set of objects that it is composed with. Anytime we can use the word has a in terms of the relationship between two classes, it's implying that composition is the form of object reuse that we are after. We'll now go along and kick open an instance of Eclipse and program up what we just saw there, and we'll see how easy it is to do. Begin by opening up Eclipse and go to the File menu and to New and Java Project. And we're going to call the Java project something really original like composition. So put in the project name, composition, and click on the Finish button down below. And this will create our project here, and it's visible in the Package Explorer. If you cannot see this Package Explorer window here, go to Window, Show View, and Package Explorer. Okay, I'm going to expand this little project tree, and you should see source and the JRE, that's the Java Runtime Environment System Library. So click on the source folder here, and we're going to create a package. And the package we're going to create is the same one you've been using so far this semester. So create a new package, and our package is going to be ie.gmit.java2, and click Finish. Okay, so we've got a package, and in the package we're going to create our student class, the course class, and the book class at the very minimum. So we'll start with the composed objects. We pretend that these have existed already. So let's go to File, New Class, and we're going to create a class called Course. So type in the class name as Course and click Finish. Now we need to put in some information here relating to course. A course itself is composed with other classes or objects. So we're going to say that a course, in this case, we keep it simple, is composed with a number, some integer value relating to the course ID and a course name. Now naturally a course would have lots of other things associated with it, but we don't need to worry about them at this stage. So put in an instance variable, private int course ID, and private string course name, and do Control S, save that, or Apple S if you're on a Mac. So I have a course is composed of a course ID, which is an integer, and a course name, which is a string. So we want to be able to chop and change these values. So create a couple of methods here to allow us to do just that by going to the source menu and going to generate getters and setters. And these are going to create a set of methods called get course ID, set course ID, get course name, and set course name. So the source menu, generate getters and setters, and it's going to say, look, the composed objects that you have, okay, which getters and setters, which ones do you want to set getters and setters for? So I want to set getters and setters for them all, and click OK. Now we can tidy up this a bit here. It's maintainability was one of the things we said OO was all about, so it should be highly readable. That's a little better there. So a class course is composed with, has instance variables, a course ID, course name, and I can get and set those values down here. Okay, let's create another new class. Click on the package, then right click, go to new class. In this case, we create a class book. And again, we're going to keep this very, very simple. We're going to put in a private string, and we're going to call it ISBN with the book number, private string title, and a private date, published date, and I'm going to put in a private float price. Now you'll notice that we're getting an error under date, and that's because date belongs in the java.util package. So to sort that out, just slowly mouse over the error, the date, and it's going to say to us, look, date cannot be resolved to a type. The Java compiler doesn't know what date we're using or where we're getting it from. So it's given us a couple of suggestions. Do you want to use the java.sql.date? The answer is no. We want the second one, the java.util, as in utilities. java.util.date. So select that one. Then click Control S, save as we go. Save causes Eclipse to compile. And we're going to do pretty much the same thing we did before. I'm going to go up to Source and Generate Getters and Setters. I'm going to go Select All this time. We'll be lazy about it and click OK. And this is going to create a suite of getter and setter methods. So we pretend that this is a fully functional book object that can do pretty much anything we ever wanted to do with a book, something that Amazon would be proud of. And our book object is composed with 4 different attributes. Okay, these instance variables: a string ISBN, a string title, a date, published date, and a float price. Okay, now we're in a position to do our student. So we're going to click on the package, right click, go to new class, and this time we create a class called student. And the student now, as we had in the notes there a moment ago on the whiteboard, has the following attributes. So it's got a private string ID, it's got a private date, DOB. Now this will start complaining because, again, the compiler does not know what version of date we want to use, or even where date is defined. So we'll have to tell it that. So just mouse over date. You can do it like we did before and import java.util.date, the first option, or you can just go up to the top here and put it in ourselves. So import java.util.star basically tells the compiler, hey, let us see everything in the java.util package. I should add, folks, that does not in any way impact does not in any way impact on the speed of anything by using the star there. It makes absolutely no difference. I'm after remembering here, folks, we should have put in the address. So we better go back, click on our package, right click, new class, and we'll put in the class address. And here we'll just put in something like private string street, and we just keep this very, very simple. Just want to illustrate the concept here. City, we're not going to bother with postcodes or air codes. County, and these are all strings. Country. Okay, and again, we're going to do source, generate getters and setters, select all, and click OK. And that's not so bad. Okay. Okay, so we have our address object. Let's go back to student and go private address A. That's what we had in the notes. We need a course object, private course C. And finally, the book array, private, okay, it's a type, an array of that type, in other words, a book array called books. Now we haven't initialized that array, so we're going to do that in a minute. Okay, right, let's do the following. Let's go to source, and we'll select generate a constructor using superclass. This will give us our null constructor, so just click the default that we're given, and this gives us our basic class constructor. So all I'm going to do here is go to books, is assign the value of a new book array, and we really should have a constant, but for the minute let's just put in a maximum of 10 books. Okay, and the final thing that we're going to do here is we're going to add some getters and setters. Sorry, this is the penultimate thing we're going to do, but we'll only put them in for one or two, just to keep one or two of these, just to keep things simple. So I'm going to go generate getters and setters, and I want set course and get course. I don't want to go into the books. I do want get address, set address, so we're going to click on those there. And because we called it A and C, it's we will have to just manually go in here and just change this a little bit. Instead of just get and set A, that doesn't really mean anything. We get and set address, get course, and set course. And this is becoming what we call a bean class. Okay, now the next step is really, really important, and I want people to understand what we're going to do or why we're going to do it before we go and do it. And it is this. The whole point of composing a student with these objects that are defined elsewhere is so we can reuse them in their entirety. And we reuse them by not reinventing the wheel. We reuse them by delegating calls to them. So I'm just going to illustrate it with one example. If we want to set the address of a student, I can call get address, or set address rather, like so. But I can also generate delegate methods to allow us to do this. Okay, so outwardly I'm going to expose the fact that the student has all this address stuff it can do, the methods defined in address, but internally all I'm going to do is when you call those methods, I will delegate those calls, just dispatch them on to the address object that we're composed with. So, go up to source, generate delegate methods, and we will just select one of the simpler address ones here. I want to set the, we'll say set country. We'll just keep it very, very simple, and click OK. OK. And we can see it here. So our student class now has a method called setCountry. If anyone goes student.setCountry, what happens is this call is delegated to the object called A, which is the type of address that the student is composed with, which brings us basically to the mantra that I want people to remember, and it is this: compose and delegate. We compose and delegate. You use composition in order to reuse an existing object, and we reuse it mainly through the act of delegation.